All right, cool. Thanks, guys. I'm happy to be here. So today I'm going to be talking about Protobuf integration in Flutter projects. Just get my notes here. Cool. All right, so I'm relatively new to Flutter. Have just been doing this for about 6 months or so. Got involved with it as part of a startup that I'm doing with an old coworker of mine. I want to talk about Protobuf because this is a tool that I really enjoy using, and I find it quite useful for the projects that I've been involved in. The presentation is going to start a little bit abstract, and hopefully by the end of it, it gets a little bit more concrete and Flutter related by the end, but bear with me a bit for the first 5 minutes as I try to sort of paint the picture of how it works. So to start off, just who has heard of Protobuf before? Show of hands. Not bad. Who's used it before? Couple. Okay, cool. Sounds good. All right, so I'll just go quickly through what we're going to talk about. Going to talk about what Protobuf is and why it's useful. We're going to use it in an example Flutter project. I'm going to talk a little bit about how we use Protobuf at Common Events. That's the startup that I'm working at, that May is working at as well, that you might remember from about an hour ago. And then, yeah, we'll get into questions at the end. I'm going to try to keep it pretty condensed, so if you do have any biggish questions, we can save them till the end. But feel free if you just got a quick clarification question you want to ask. Okay, all right. So what is Protobuf and when do we use it? So it is a tool for defining structured data types in circumstances when these data types that you're defining are shared between multiple programming environments. So if you have a programming environment where you use Python, one where you use Flutter, but these two environments need to work on the same common shared data structure, Protobuf is a really excellent tool. Additionally, it is best when you have control over these different programming environments. And we'll see why here in a second. So we're going to go through an example that isn't Flutter related at all. Drone dam inspections with drones that will be Flutter related toward the end. So I chose this example because it's something a friend of mine does, and I think it's a really good use case for Protobuf. What his company does is they build drones that have a big suction cup basically on them. So they go to dams and other large infrastructure projects, fly the drone up, the suction cups sucks onto the side of it, and they do analysis on the dam, look for voids in the concrete, leaks, things like that. And it's a really good example of when to use Protobuf. Okay, so in this circumstance, when we've got a drone inspecting a dam, what's going on? So we have the dam, obviously, and the drone's flying around it, and there's an operator piloting the drone as this is all going on. So while this is going on, the drone and the operator are in constant communication, transmitting information like what's the drone altitude, battery level, information from the engineering instruments and analyzing the dam. And these are very much totally different programming environments. You have your drone operator who's running with probably a Windows or Linux application, a lot of custom code on this machine. It's on a laptop, so you have plenty of memory. And on the drone, it's a much different thing, probably written in C. You've got maybe a couple megabytes of memory working on a microcontroller. Very different circumstance. So I'm going to extrapolate from the situation a little bit and make the assumption that sometimes the dam operator likes to come by and watch this work go on. And when he's sort of looking over the shoulder of the pilot operating the drone, we're just going to assume that doesn't go very well. Stresses the pilot out. If errors pop up on the screen, probably not something the dam operator really wants to see. So we're going to take the owner, operator, whatever, of the dam, and we're going to put him over there. And we're going to give him his own view of what's going on with the inspection and with this situation. And this third programming environment is going to be probably a web application, something that just shows a little bit of information about the job that's going on. Less information than the pilot sees, and different programming environments. So we now have 3 different sort of domains where things are going on. But what do all of 3 of these have in common? is that they're all operating on a shared structured data format. And what that shared structured data format is the information coming from the drone. So things like I was saying, battery level, telemetry, altitude, all that information needs to be accessed by these 3 distinct environments. And they all need to be speaking the same language, essentially. So all 3 of these programming environments need to see the fields that they expect to see related to the drone status and be able to operate on them all at the same time. Okay. So it's very similar in the way that Flutter allows you to make a common UI definition in one place and have one source of truth. You define what your app looks like, how it functions, and from that one place, you get outputs for Android, iPhone, Windows, and all the other Flutter outputs. Very similarly to how Flutter is structured this way, Protobuf is when you have a common data definition rather than a common UI definition, and you need to export this into different programming languages and different programming environments. Do you have a question, quick?
Yeah, because
yeah.
I also use Protobuf, but you could also do what all you've defined in OpenAPI v3, you get the same result. Yeah, I've mentioned the real advantage of Protobuf, which is in-memory network resources are way less necessary compared to OpenAPI on the hardware, and networking, in terms of network, you have 7 times less network because it's not human readable.
Right, yep. Yeah, there's quite a few advantages that come with Protobuf, like just quite significantly reduced size as compared to JSON or some other types of ways of communicating information. And then the advantages that I really find personally beneficial, we'll get to in just a sec with some code examples. What do we have here? All right, cool. So let's go ahead and do that. Let's do an example here. So we're just going to kind of extrapolate off of this drone example and work it in code a little bit here. Okay. All right, so we're going to start. Can everybody see in the back? Is that big enough? Thumbs up, yeah, cool. So we're just going to start with a class containing information that you would expect to probably see coming from a drone. We're going to do stuff like, oh, I have a mouse, nice. We're going to do things like the general status of the drone, speed, altitude above the ground, altitude above sea level, if that suction cup engineering analysis thing is turned on. And, sorry, a little bigger. Yeah, there we go. So we're going to make our own little proximity status class here that contains basically just information about, is there something immediately to the left, right, front, back, top, and bottom of the drone. Make sure it doesn't crash into anything. Cool. So now let's make a super simple Flutter app to display this information. I'm just going to skip through most things here, and I'm going to point out this place where we are defining a variable called drone status of type drone status that we just defined. And this is where we're going to store our information about the status of our drone. As we start our Flutter app, we're just going to initialize it and start a timer. This timer is simply every second going to run this function. What function is it running? We're just going to run update drone status. What does this do? A whole lot of nothing very interesting. Going to generate some random numbers and put them into our app such that we can see them. Then the rest of our Flutter app is just going to display that data. Nothing exciting so far. Let's go ahead and run this. Flutter builds take between 3 to 5 business days. So. All right, beautiful UI, right? So nothing particularly interesting. We're generating some random values, putting them into this drone status structure, displaying them in our Flutter app. All right, so since that's not that interesting, let's close this out and go to sort of the next step in this Protobuf integration process. So if I can fit all this on the screen. Right. So what I'm going to do now is we have our drone status class that we originally defined on the right. And what we're going to do is we're going to define this essentially the same information in a .proto file. And the .proto file is the Protobuf file extension that's used for defining the structure of our data in a programming language independent way. So this has nothing to do with Dart or Python or any other programming language. It's defining your data, in an agnostic, independent way. So we're just repeating the same information. We have our proximity status, general status, speed, altitude, blah, blah, blah. Cool. All right. So what we're going to do now is we're going to go back to our Flutter application, and we're going to delete this class that defined the structure of our drone status data. So, as expected, now we have a couple errors because this type does not exist for drone status. So, in this next step of integrating Protobuf, what we're going to do is, can I make this bigger? Yeah. What we're going to do is we're going to use the Protobuf compiler to take in this data structure definition and output Dart files that are essentially a representation of that class. So let's go ahead and do that. All right, so we've done that. And we can see on the left here, we've got 4 new files that have appeared. If we look at these are the Protobuf generated outputs from our .proto file. There's a whole lot of code generation weirdness going on, but basically the core piece that's important to note is we now have a class called drone status, just like we did originally. However, this one has been generated from the Protobuf compiler. So if I go back to our original Flutter application here, let's delete the import for the old manually created class. Let's import the Protobuf generated class, and we can see that it works just the same. It happily, takes that Protobuf class in without any modification, just like it was functioning before. Cool, and as you can see, same thing. All right, also not that interesting. So we've defined a class in Dart. We've taken the data definition out of Dart, put it in another file, and then generated it back into Dart. What's next? Yeah, question quick.
Let's say in the use case where you define your Protobuf definitions and you generate the initial file. But let's say, for example, I don't know, there's feature refactor and you're rebuilding things, and say in the process, the name of the data structure changes. Is there a function that will not only, for one, generate the new definition, but also to adjust your imports and your references to those imports?
Right. So I'll show an example of doing a rename in a little bit. There's also a lot of baked-in Protobuf features that are super helpful with backward compatibility and schema changes, just like you're talking about. And if I had an hour, I would love to show you guys all that. But I'll get a little bit of taste of it toward the end so you can see. But then, I invite you to check it out. Okay. So, all right. So we have now. So we've generated our Protobuf structure. We're still generating these random values locally. So again, this is kind of not that cool yet. So let's take the next step. Let's go to the next thing here. So I am going to now, instead of generating these random drone status values in Dart / in Flutter, we're going to generate them in Python. So this code is essentially just recreating the steps here on the left in our Dart application, where we're generating our random values. We're now going to do it here in Python. All right. Now, let's take this Python code and let's put it somewhere else. I'm going to copy and paste this. Oh, sorry, excuse me. No, yeah, we'll do that in a sec. So I'm going to copy and paste this Python code that generates these random values, and we're going to put them in an AWS Lambda function, which for those of you that don't know is essentially just a way to run some code, in AWS, not worry about servers. It will just give you a HTTP endpoint that you can call and receive the results of this code running. So we're going to copy in the Python code that I have here. And also what we're going to need to do is we're going to need to generate the Python output with the Protobuf compiler for our drone status data structure. So we'll do that here and like that. Cool. And now we can see we've got a Python-generated code that the Protobuf compiler has spit out. So we're going to take this. We're also going to put this in our AWS Lambda function, and we're going to deploy it at this HTTP endpoint. Cool. So some of you might be thinking, great, we're generating random numbers in Python in AWS somewhere. How do we get that data back? Because we're just defining, oh, you guys can't see really. We are essentially just doing the same thing as before. We're defining a variable, populating it with values, and then that's kind of it. So the real key feature of Protobuf is it allows you to take this variable that you've defined, populated with values, this variable that matches your Protobuf data definition, and you call serialize to string, which essentially takes your native Python object or Dart object or C++ object or whatever Protobuf data structure you're working with in the language you're working with, and convert it into a blob of bytes. And you can then take that blob of bytes and ship it across the network and pick it up by any other software that is utilizing Protobuf and expects your data structure. So that's what we're doing here. We've got our drone status, serialize it to a string, do some encoding steps and some logging steps, and then we're going to return that data back to whoever is the caller of the HTTP call of the Lambda function.
So you're saying
Yes.
we can transfer this Python encoded, this data to Dart?
Right.
Is data created by Python to Dart via the network?
Right. So this information is generated in Python. It's then stored as this blob of Protobuf language agnostic bytes, shipped across the network, and then on the Dart side, what we can do is we can get rid of our local code that is generating these random values in Flutter. Get rid of that. And instead, what we're going to do is we're going to fetch the status of our drone from this remote endpoint, from this Lambda function endpoint right here. And then from the information that we get back from that request, we're going to create a new variable. This part's the key. We're going to create a new local Dart variable of type drone status, which is the Protobuf definition. And we're going to populate its members with information that comes from this blob of bytes we received from that HTTP endpoint. So if we do that, get rid of that, save it, and run it, you get, ta-da, the same thing. So we are now going to, so now we're fetching these values from remotely, just like we were generating them locally before. Now we're generating them remotely and bringing them in to our Flutter application. Yeah, question?
This is an example, right? You would really not want to do this in real production because you won't have gRPC error. You would rather use gRPC embedded in this case, right?
Say it one more time.
This example is a custom example of serialization through base 64, but in real apps, you wouldn't have any error handling either. It systematically break on network, and you'd have huge network issues.
For sure.
The
Yep.
method you would need to use gRPC web, and in this case, even gRPC web server stream to get the stream of data. It's just for everyone else to be aware. Don't do it like he did, but the Protobuf method is very appropriate. It's just in the networking aspect. You don't want to use Protobuf over HTTP. You want to use gRPC or gRPC web.
Right, yep. Except for demos. Yes?
Can we see the drone status proto?
So,
I don't understand how
this one?
the Protobuf make all of this.
The generated code, or the, yeah, generated code.
I mean, how does it generate?
Just with the Protobuf compiler.
This is fine. Like,
Yeah.
did you like define everything in the .proto file?
Yes. Yep.
Okay.
Yeah. So this is the handwritten part of the data structure definition. Yep, is in the .proto file.
And what are the use cases that we need this situation?
Yep. Yeah. So let me show you. Getting a little bit close on time, but the circumstances. Just save that. Cool. So the circumstances where I find this really valuable is when schema changes occur. So let's back up for a second and look at what we're doing. We've got our common data definition that needs to be the same in these different programming environments. We've taken that common data definition, utilized Protobuf to export generated code in Dart and in Python. And what we can do here is if the schema does change, such as we rename general status or system status, general status to system status, if we add this field, and if we remove this field, and then go through our Protobuf generation step again, what you'll see is anywhere where the fields have changed, a bit hard, so zoomed in, anywhere where the fields have changed in your Python or in your Dart outputs, now you've got compile time warnings that are telling you, hey, the schema has changed, you have to deal with your code that is using them because things have changed. So just that by itself, rather than needing to worry about synchronizing JSON schema definitions in sort of like with a plugin or with an add-on, et cetera, you just have native classes and native objects right in whatever programming language you're working with. And when a change does happen to the data structures you're interacting with, you know right away, just simply from IDE warnings. And again, there's a lot of really cool Protobuf backward compatibility stuff where even if I fix one of these programs and run it and send the generated data to software that's using an old schema version, it's not going to work as expected, but it's also not going to explode. Basically, if I remove a field in my Python API Lambda function and then send it to an old version of the app that is running the old schema version, that field will just be blank, basically. But you won't get you won't get runtime errors. The app isn't going to blow up. You're just going to have an empty field, empty value, and you can figure out as a programmer what to do about that. So, good on time? Yeah, cool. All right. So, let's go back here. Okay, so this is just reiterating what I had just said. We're common data structure, protofile, Dart, and Python, et cetera, et cetera. And then, yeah, the key piece is that this is generating native objects for you. So you don't have to do anything special in your language. You just work with objects as you normally do. And you get these added benefits of being able to interact and communicate with other platforms. So when are the circumstances when this does not make sense? If you're only doing one programming language. Obviously, this is kind of useless and overkill. If you are using multiple programming environments, but you don't have full control over all of them, then this doesn't really make sense, because if you make schema changes, you need that code to be able to go into each one of these different environments for things to work. Also, if your data definitions don't really change that often, if only every couple months you're adding a field or something like that, this is again kind of overkill. And of course, if you do enjoy dealing with type errors or missing field errors in production, don't use Protobuf. All right, so I'm going to talk super quick about common events. So this is the startup that I'm working on with an old coworker of mine. And we're essentially an event management platform that keeps track of who you ended up speaking with during the event via Bluetooth. So your phone's always keeping track of how close you are with other participants. Lets you sort of talk and socialize with people naturally and worry about finding people and connecting with people that you spoke with until after the event is over. So we use this pretty liberally. It's ends up being a little bit more boilerplate than is probably necessary. But essentially, we just have our two programming environments. We've got our Dart or Flutter application, and we have our API. They're totally separate. API is written in Python, runs in AWS. Let's see. Yeah, we have just those two environments, and data is being transferred back and forth to run our app. And what we do is we define a Protobuf message type for essentially each API request and response. So anytime anything goes up to the clouds from our Flutter app down there in the corner, it gets handled by one one Python function that figures out what data is contained in this, what kind of request is it, and then it gets sent to individual Python snippet files that are the handlers for that API function. So main benefit of that is essentially what you saw before. Anytime our schema changes, we add new API endpoints, rename things, have to rejig things. We can see in both programming environments where we're using those fields, where we need to deal with things, and allows just changes to happen, deals with the complexity at compile time rather than pushing it into being a runtime issue. So if this looks interesting, if working in an environment where we're using Protobuf a lot sounds interesting, please come and talk to me after. This is pretty recent. I've been doing this with myself, co-founder Dex, and May for just sort of since December or so. Made first commit on, I think, January 27th, and we've got about 10,000 lines worth of somewhat decent code, I like to think. So we're working on this. I've been really enjoying it, and because it's very recent and because we have no funding, we can offer you a fairly competitive salary of $0. However, obviously, we're all going to need money at some point. So this isn't sustainable for the long term for me or anyone. So even though that's the case right now, do please come and talk to me, because if you would like to get involved at a later date when we can pay you, I would love to talk to you and hope, look forward to it. Final thing before I wrap up, thank you guys to the hosts for giving me these wonderful template slides. It was actually really nice. Didn't have to worry about styling. I am not at all a graphic designer, so it would have come out much worse otherwise. However, this last slide had a really big place to put a photo, and our logo looked a little bit weird like that, I thought. So our co-founder Dex goes to a lot of these networking events where they have pizza quite often. And for some reason, I think it's happened 5 times now, when the photos of the event come out, he's always eating pizza, side-eyeing the camera like this at these events. So that seemed like a more appropriate thing to put in the final slide. So I will leave you with that. And guys, thank you for your time. Appreciate it.